there's a subtlety here that I want to point out to you. Let's consider the domain of the function x minus 1 divided by x minus 1. So you might think that anything divided by itself equals 1, so f of x is really the same thing as the constant function 1. I can just simplify the function to be that. And the domain of this function is obviously all real numbers. So does that mean that the domain of the original function, before we simplified it, is also all real numbers? And the answer is no. It is true that anything divided by itself is 1, unless that thing is 0. 0 divided by 0 is what's called an indeterminate form. It means that the numbers isn't defined. And that's just another way of saying that f of x equals 1 for all real values except 0, and it's not defined for 0. If you were going to imagine what the graph looks like, you could choose any values you want along the x-axis, and you're always going to get a y value of 1, unless you choose the x value 1, which produces 0 over 0, and so that gives you a hole in the graph. So here's the graph of the original function. So all of this is just to say that you can't simplify and then find the domain of the simplified answer. If you're interested in combining functions together and then finding the domain, you have to think about the domain before you do the simplifications. So here's two common examples. If I was going to take the square root and then square it, obviously that simplifies to be x, which would imply that the domain here is all real numbers, but it's not. And here, if I have x times 1 over x, again, that simplifies to 1, and so it would seem like the domain here is all real numbers, but it's not. Take a minute and figure out what you think the domain of each of these are. For h, the domain is x has to be greater than or equal to 0, and for g, the domain is x not equal to 0.